We have learned all the 6 trigonometric functions. They are sine, cosine, tangent, cotangent, secant, and cosecant. And we notice that they're all kind of related. And today I'm going to show you their further relationship. And I'm going to use, I'm going to let you know the easy way to remember that. Okay, first of all, there's a reciprocal identities. Some of them are reciprocal of another. So this section, we call this, we're going to call this a trigonometric identities. Okay, now we know sine theta is 1 over, sine theta is the reciprocal of a cosine theta, or cosecant theta is 1 over sine theta, right? And we also know cosine theta and secant theta, they are the reciprocal of each other. It's 1 over cosine theta. And at the same time, we know tangent theta is 1 over cotangent theta, or cotangent theta is 1 over tangent theta. Okay, so all those is called reciprocal identities. You probably don't really need to know the name, but you know this relationship, okay? And if you remember that we have the sine theta is y over x, y over r, and we know cosine theta is x over r, and the tangent theta is y over x, which is the sine theta over cosine theta. Did you notice that? Because the tangent is this over this, and this is r get canceled out, so you get a y over x. Okay, at the same time, we have the cotangent theta is x over y. Okay, the reciprocal of that, which is cosine theta over sine theta. And what is that called? This is called a quotient. Let me just write here. This is called a quotient identities. Okay. All right. Now there's one more. If you remember that we learned a little earlier, we have the sine theta, which is y over r, and we have sine theta, which is cosine theta is x over r, and the sine square plus cosine square, that is y square over r square plus x square over r square, and the top x square plus y square is r square over r square, so it's 1, right? Okay, at the same time, we will have another one that we call this as Pythagorean identities. Okay, so you might think, how can I remember that? I tell you, I think this is a very valuable class, because in this class, I'm going to tell you a very easy way to remember all those identities in a simple graph. And then I'm going to show you how to use that to work on some questions. So let me ask you to do this. You write sine theta, cosine theta. Okay, and I ask you to write tangent theta and a cotangent theta. And I ask you to write a secant theta. On the left side, I have a sine tangent secant. And the right side, I have a cosine cotangent and a cosecant. So I put all the cos on the right, and then I do this. And I put the number 1 in the middle. All right? So I'm going to connect all of them into this little circle. It's a magic little circle. All right? And then I ask you to shade these 3 triangles. Okay. First of all, the reciprocal identities, sine is the reciprocal of cosecant. Tangent is the reciprocal of cotangent. Secant is the reciprocal of cosine. Cosine is the reciprocal of a secant. Okay, and cosecant is the reciprocal of a sine. Cotangent is the reciprocal of a tangent. Okay, and remember that tangent is a sine over cosine. So as long as you go by whatever order you go, here's the first term, here's the second term, here's the third term. No matter it's a curved or straight, 1 is always the second term over the third term. Okay, now let's see. Sine is 1 over cosecant. Tangent is 1 over cotangent. Secant is 1 over cosine. And the cosecant is 1 over. See, you can also go backwards. It doesn't matter which direction. Okay, you can go this way or this way. So cotangent is 1 over tangent. Did you see that this graph showed you all the reciprocal identities? Yet, not only that, it also shows you the quotient identities. Tangent is a sine over cosine. Sine is cosine over cotangent. Cosine is sine over tangent. Okay, you can kind of think this is the same. Okay, so sine is 1 over cosecant. You have to go straight through. Okay, you cannot just go curved. So cosecant is cotangent over cosine. Isn't it interesting? Because this one shows you, if you can remember that, it's already include the reciprocal identities and the quotient identities. It shows you all those. What about this? What about the shaded triangle? Okay, so this is 1, this is 2, this is a 3. Okay, so that gives you 1 square plus 2 square equals a 3 square. Let's see, what do we have? We have a sine square theta plus cosine square theta equals 1. 1 square is 1. At the same time, I also get a tangent square plus 1 is a secant square. One more. So I get a 1 plus cotangent square equals cosecant square. So those are the 3 Pythagorean identities. All right, now I ask you to remember this by heart. Okay, I don't see many textbooks in the United States show you this, but I learned this in my high school, so I ask you to remember this and this. Okay, once this is like the magic paper. Okay, so once you have that, we can do a lot of things. And today I'm going to use this to do this. Simplify. Okay, I ask you to simplify this. I ask you to simplify tangent x times cosine x. Tangent and a cosine. Here's a tangent, here's a cosine. All right. Now, tangent is a sine over cosine. Okay. So if I simplify that, it's going to be sine x over cosine x. Okay. And I go ahead and multiply by cosine x. Get canceled out. So I simplify that, I get a sine x. It's very easy, isn't it? Okay. Now I'm going to ask you to do a little bit further, a little bit more complicated, which is simplify this. Sine x over cosecant x. Okay. And I go plus cosine x over secant x. Sine over cosecant. Okay, sine over cosecant. Wait, they're not the same, right? But I know the cosecant and the sine is reciprocal of each other. So can I do this? Can I write cosecant equals 1 over sine? So if a cosecant, here's the sine x. If I write that as 1 over sine x, at the same time I write a secant as, here's the cosine x. I write that as 1 over cosine x. I can do that, right? And then a sine x divided by a fraction, which means you multiply by the reciprocal of that. So it's going to be sine x times sine x. That equals, plus cosine x times cosine x, right? You divide it by divide by a fraction, which means you multiply by the reciprocal of that. So you cannot like flip this to the top. So that is a sine square x plus cosine square x. You should be very familiar with this already, right? Sine square plus cosine square, which is 1. So you already simplified that, which is 1. Okay, see, you can use this to simplify. Let me give you one more example. I do simplify. Simplify this. Tangent t plus cosine t over 1 plus sine t. In this case, that angle is t. It doesn't matter, t or theta or x. If I ask you to simplify this till the final, like a clear formation or clear function without this fraction thing. So what I would ask you to do is do this, sine t, tangent t, plus. Now, did you notice the denominator is 1 plus sine t? If I multiply by 1 minus sine t, I'm going to get a 1 minus sine squared t, and I'm going to get a cosine. So the numerator and denominator, I multiply by this together, okay, for this part. Then the top, I get a cosine t times 1 minus sine t. And the denominator, I get a 1 plus sine t, 1 minus sine t, I get a 1 minus sine squared t. You can either use a plus b times a minus b, which is a squared minus b squared, or you can use the FOIL. You should get the same thing. But the good thing is we have a 1 minus sine squared t. That is cosine squared. Now, we have a tangent, we have sine cosine. I prefer to change everything to be sine cosine. So this is the sine t over cosine t. Okay, now plus. Here is a cosine t, and here is a cosine square t, and the top is 1 minus the sine t. Okay, did you notice that you can cross this with the square? So the denominator, you get a cosine t. And then the top, you have a sine t, you have a plus 1, you have minus that. So you should have a 1 minus cosine t. And if you write that without writing this fraction form, it's going to be secant t. That's it. So did you see that? You simplify from here all the way to here just by using all the properties or the identities that we learned. Okay, so this, again, I want to simplify all those expression of the trigonometry just based on this. I call this as a magic graph. Okay, you can call this as Professor Wu's magic graph. That's what I learned long time ago, and I want to share this with you.